Today we're going to learn about simplifying radicals. And the word radical is just another word for square root. So just to remind you what a rational number and an irrational number. So a rational number is a number that can be expressed as a fraction in the form of p over q, which means writing it as a numerator and denominator, where p and q are integers and q is not 0. So for example, 2/3 would be rational. The number -5 would be rational because I can put it over 1. The square root of 4 would be rational because it's equal to 2. An irrational number is a number that cannot be expressed as a fraction with integer values in the numerator and denominator. So there are only 3 types of numbers that are irrational. That would be pi, anything involving pi, because pi is a number that just goes on and on forever. Non-terminating, non-repeating decimals like 2.769 ... meaning that there's no pattern. And also square roots of non-perfect squares, like the square root of 7. Which that's what we're going to learn how to simplify today. And then perfect square, because it's a word that I'm going to be using a lot, is the product of a rational number multiplied by itself. So for example, 16 is a perfect square because 4 times 4 is equal to 16. So in the first problem, we're just going to go through our perfect squares, and it's very important that you memorize your perfect squares at least up to 15, because it just makes it easier. So what number multiplied by itself gives you the following number? So 1 would be the product of 1 and 1. 4, the 2 identical factors that multiply to give me 4 is 2. So 2 times 2 is 4. 9 would be 3 times 3. 16 would be 4 times 4. 25 would be 5 times 5. 6 times 6 gives us 36. 7 times 7 gives you 49. 8 times 8 gives you 64. 9 times 9 gives you 81. 10 times 10 gives you 100. 121 would be 11 times 11. 144 would be 12 times 12. 169 would be 13 times 13. And 196 would be 14 times 14. So the perfect squares are 1, 4, 9, 16, 25, 36, 49. They're the products. So in number 2, we want to find the perfect square factor of the following numbers. So 4, the factors of 4 are like 1 and 40, 2 and 20, but we want to pick 2 factors, one of which is a perfect square. So if I look at my perfect squares here, well, 4 is a perfect square. So 4 is my perfect square, and it multiplies with 10 to give me 40. So 128, if I can't think of my perfect square, what I want to do is I want to take 128 and just divide it by a perfect square and see what the other factor would be. So 128 has a factor of 4. And if I take 128 and divide it by 4, it gives me 32. But I want to see, is there a larger perfect square? So maybe I'll try 16. So if I take 128 divided by 16, that gives me 8. So 16 times 8 is also 128. Is there a larger one? So I can just play around and do 128 divided by 36. That gives me a decimal, so it doesn't work. 128 divided by 49. That doesn't work either. 128 divided by 64. That works. That gives me 64 times 2. So this would be the largest perfect square. 64 is the largest perfect square factor. So all I'm doing is I'm taking the numbers and I am dividing by a perfect square to find out what the factor would be. So let's look at E, 147. So if I take 147, divide it by, let's see, 9 I'll start with, because I know 4 wouldn't work because this is an odd number. So if I divide it by 9, I get a repeating decimal, so that's not going to work. So let me try 49. So 147 divided by 49 gives me 3. So 49 times 3 is 147, so I know my perfect square factor is 49. So what I'd like you to do now is I'd like you to pause the video and see if you can determine the perfect square factors for the remaining problems. All right, so check the rest of your answers. So for 75, 25 would be the perfect square factor because 25 times 3. D, 20, the perfect square factor would be 4. F, 243, the perfect square factor would be 81. For G, I think we did that one already, 121. H, you should have had 9 because 9 times 3. Number 8 would be 4 because 4 times 2. And number 32 would be 16 because 16 times 2 gives you 32. Okay, so now let's turn to the next. Okay, so now we're going to talk about square roots and how you would simplify a radical. So for every positive number has 2 square roots, one positive and one negative. So for example, the square root of 25 is 5, and the square root of 25 is negative 5, because 5 squared is 25, but also negative 5 squared is 25, because when you multiply 2 negative factors together, it gives you a positive. So when we are finding the square root of a number now, we're going to express it as it's positive 5 and negative 5. So we're going to determine the square root of each number. So the square root of 9 would be plus minus 3, because 3 squared would be equal to 9, but also negative 3 would be equal to 9. The square root of 36 would be positive 6 and negative 6, because 6 times 6 is 36. The square root of 169 would be positive 13 and negative 13, because 13 squared is 169 and negative 13 is 169. So I'd like you to go through the rest of the problems and find your square root of each. Okay, so now we're going to learn how you would do operations with radicals. So we can combine perfect squares to do some operation. When we do these operations, we use only the positive value of the square root. And when we're simplifying, we follow PEMDAS. Parentheses, exponents multiply or divide, add or subtract from left to right. And square roots would fall underneath exponents because square rooting is the opposite of squaring. So let's look at example number 1. So number 1, we have the square root of 18 minus 2. So what we're going to look at example number 1. So we have square root of 18 minus 2. So because we have that operation underneath that radical sign, we have to do that operation first. So we keep our radical sign. 18 minus 2 is 16. And then we can take the square root of 16, which would be 4, because 4 times 4 is 16. Number 2. So we have radical 3 times 4 plus 13. So following order of operations, we have to do our multiplication before we add. So I keep my square root sign. 3 times 4 is 12. Bring down my plus sign, 13. Then I have to add together 12 and 13, which would be 25. And then I could take the square root of 25, which would be equal to 5. Example number 3. we have the square root of 49 plus the square root of 100. So since we don't have an operation taking place underneath the radical sign, we're just going to take the square root of each of these numbers, and then I will do my adding. So the square root of 49 would be 7, the square root of 100 would be 10, and 7 plus 10 would be 17. Number 4, we have the square root of 144 over the square root of 9. So the square root of 144 would be 12. The square root of 9 is 3. And then 12 divided by 3 would be equal to 4. Number 5, 2 square root of 16 plus 5. So here 2 radical 16 means the 2 is multiplying with the square root of 16, and then you're adding 5 to it. So what we would have to do here first is take the square root before we multiply, because remember, square roots fall underneath that exponent. So I keep my 2. That's going to multiply with 4 because the square root of 16 is 4. Bring down my plus 5. Now I'll multiply. 2 times 4 is 8 plus 5, and 8 plus 5 would be equal to 13. Okay, so let's look at the last example, number 6. So we have the negative square root of 81 minus 10. So we take our square root first, which is 9, but we have to make sure we bring down that negative sign that was in front of the radical. Then I bring down minus 10, and then I'm going to do negative 9 minus 10, which is negative 19, because these both have negative signs in front of them. Remember, same sign, you add and keep the sign. So what I'd like you to do now is I'd like you to do the try yourself problems, or the practice problems numbers 1 through 4. And when you're done, just make sure you submit your answers. But tomorrow I will also put up the work that goes along so you can check to make sure you're following the correct process. Remember, if you have any questions, just email me or send me a message through Google Classroom at any time. All right, have a great day.